In this video, I'm going to introduce you to friend functions and friend classes. You may be thinking, wait a minute, this lesson is about operator overloading. Why are we talking about friend functions now all of a sudden? Well, when we overload operators as global functions, we need access to private data members. And as I talked about in previous lectures, we don't necessarily want to provide getter functions for all of our private members. So what we can do is we can declare non-member functions as friend functions, and then those friend functions have access to private members. And we'll start with friend functions, and then later on in the video we'll talk about friend classes as well. Sometimes we want to give a non-member function the ability to access the private members, so the variables and the functions of the class or the struct, and in that case we can declare the function as a friend using the friend keyword. You can do that anywhere in the class or struct definition, and that friend can then access the private members directly. Here's a friend function example. I define the entity class, and within that I define the toString function. It is void, but you can see the keyword friend is also used here, so that means it is a friend of this entity class, and we can access the private members of this entity class directly by doing the object name, so in this case entityp.member, so within that console output statement. Just like with the member functions, you can have the prototype within the body of the class, and then end that off with a semicolon and then go and define the function outside of the class. But again, to specify that function as a friend, you want the prototype in the body of the class, and you want to specify that as a friend using the friend keyword. I have a quick example in Visual Studio of where a friend function might come in handy. Now you remember this example from the lecture on the copy constructor. So here I have the default constructor, and then here I have a copy constructor, right? Now we do not have a member pointer here, we simply have an integer called a member. So once again using this entity class, and to demonstrate when the copy constructor gets invoked, what I did was I used this toString function right here, and then I also have this member function, this getMember function, which returns the member. In the main function, I construct entity1 passing the argument of 3, and then I do toString and I pass in entity1. Alright, I build and run that, and we get copy constructor invoked, and it prints out 3. Now you can think for a second how this can be improved by making this toString function a friend of the entity class, because then we don't need this getter right here, which is in the public section of the entity class. Okay, and that helps us to get the value stored in this member variable. So I'm going to delete that getter, this getMember here. I'll cut out that toString function. Okay, and right before the public section, I'll go and define the toString function as a friend of this entity class. We can do entityp.member, even though member here is private. If this toString function was not a friend, then of course we cannot do this. Then we'll have to use a getter, or what we can also do is we can make that member public, as in a struct, for example. With a class we typically don't want to do that, so we keep member private instead, and then we do a friend function. So of course we cannot simply write member here, because you have to remember this is not a member function, it's a non-member function. So it does not use the this pointer behind the scenes to access the current object or the calling object. And here in main you can see we don't do entity1.toString or something like that, like you would do with a member function. We simply write it like this, toString, and we pass in entity1. Copy constructor invoked, and it prints out 3 just fine. Just as a bonus, let's look at separating the friend function declaration and definition. Let's go and do that. I'll actually copy that entire thing. Then I'll delete the body. And I'll end this declaration or prototype off with a semicolon. And then outside of the class, we can go and define the function. Note here with the definition, I'm not specifying it as a friend again. You specify that explicitly within the body of the class, so within the class definition. Okay, so only once right here. That is a friend. This right here is simply the definition. Build and run, and this will work fine. And then another thing to note is if I cut that out and I paste it somewhere else, alright, this friend or this prototype right here, okay, that is currently in the private section, but it doesn't matter because remember that this friend, this toString function right here, is basically a global function. It is not a member of the entity class, it is just a friend of the entity class. So it is still a global function, right? Whether you declare and define it within the definition of within the body of the entity class, or whether you declare it inside and then define it outside. So in other words, you separate out the declaration and definition. It doesn't matter, that friend function is still a global function, or in other words, a non-member function. Okay, so even though this is now in the private section, if I build and run, this will work fine. And of course the same thing if I put it here in the public section as well. Okay, I'll undo this a couple of times just to show you this one more time. I'll cut that out, paste it right here in the private section. So we now have the declaration and definition in the private section. That will work fine. Because even though you are now declaring and defining it right here within the body of the entity class, it doesn't matter this is a friend, it's not a member, it is still a global function. Okay, so a non-member function. Next I want to talk about class member functions as friends. In the definition of a class or a struct, you can grant friendship to the member functions of other classes or structs. And now those member functions can access the private members of the friendship granting class or struct directly. So it might be a bit annoying I'm using class/struct here in these slides, but you have to remember with C++, a struct and a class is basically the same thing. That being said, it's not likely for you to use friends in structs. So as I discussed, structs are typically data containers or used as data containers. So their variables and functions are typically public anyway. So unless you are doing something specific, you won't have friends in your struct. Okay, really simple, a really concise example for you here in Visual Studio. There's quite a bit of back and forth with this example, so again, I'm trying to keep it concise and as simple as I can. Right at the top here, you can see I have class B and then class A. Now, this right here, class B semicolon, okay, that statement is a forward declaration. It declares the class B. Down here we have the definition. In previous lessons I talked about the fact that you can have, just like with functions, where you can have a prototype for a function and a declaration for a function. You can also have a declaration for a class and a separate definition. Now why is this important that I forward declare the class B? Well, because we are going to use it right here in the definition of class A. Okay, so right here we have class A. Then in the public section right here I have these two functions, a toString function and just some other random function right here, void func for function. And notice the formal parameters for these functions. Okay, notice right here this is a reference to a class B, that is our custom type, class B. The parameter here for toString is a reference to B constant, whereas this function right here is just a reference to B. And because we use it right here in the declarations for these functions, we have to go and forward declare class B right here. Okay, let's move on here for a second. I'll get here to class B. In class B, we have a friend. We specify toString here as a friend of class B. To specify a member function of another class as a friend of this class, we need to fully qualify the name. So we do A here, that is for class A. Okay, A here means class A. As you can see, if you hover over it, it says class A. Then you do here the scope resolution operator and then the function name toString. And so basically the rest of the signature of the function is right here as well. That is also a const qualified function, and it returns a void as well. This function now, toString of class A, that is now a friend of this class B. So what does that mean? If you take a step back and you're trying to figure out exactly, this back and forth, what does this mean exactly? Well, what this means is that particular function, that particular member function of this class, in this case class A, now has access to the private members of this class, or class B, basically all of the members of this class B, And of course that means we do not now have to use getter functions to access the private members of this B class that is within that toString function. And I'll actually move down here to the definition of that toString function. In this case, this is a member function, not a global function. Okay, so you can see we have void, class A, the scope resolution, and then toString. So it's just a regular definition of a member function. And then we can do console output b.member. B here is the name of that reference. We can simply do b.member instead of having to do some getter function. You might be thinking, what's the deal with all these const? Well, I could actually have removed them for this example to try and simplify things. But of course this is a toString, so we do not want this function to change the state of the calling object, which will be an instance of class A. And we also do not want the function to make changes to whatever object we pass in as an argument, which will be an instance of class B. Okay, you'll pass in an instance of class B. And so because you also don't want to make changes to the argument, you make that a reference to B constant. So you should be comfortable with that sort of stuff at this point in the course. I'm going to come back to this later on here. Okay, then in main, I instantiate A and B. I create objects A and B. Then I simply do a.toString and I pass in B. If you think for a second what's going to happen here, it should print out 5. In class B we have a private member here, int member, that is initialized to 5. We do a.toString, that is going to call this toString function. It takes in that B object as an argument. Remember, this toString function of class A is a friend of class B. So in the toString function we can access the members directly, even though those are private. Okay, if I build and run this prints out 5. Okay, remember in the definition for class A, we have this function called func. Now you'll notice that this is not a friend of class B. We only have toString here as a friend of class B. Here is the definition of that function. We have A, the scope resolution operator, and then right we have the definition. I'll uncomment this line now and see what I'm trying to do is I'm trying to do b.member, just like I'm trying to do in the toString function, but this won't work with the func function because it is not a friend of class B, right? You can try and build and run this and you'll get an error. Cannot access private member declared in class B. I'll just comment that out and we'll move on here. Let's get back here to this forward declaration. I'll comment that out and now we'll try and build and run this. And all of a sudden we'll get a bunch of errors. This error on line 9 here, missing type specifier, int assumed, and you get a bunch of errors now. And all of this has to do with the fact that program execution is sequential, alright? So when program execution reaches these lines, it doesn't understand what B is, and that is why you have to forward declare it like that. And the same thing goes for when you declare a friend, like right here. You fully qualify the name, so you do A and the scope resolution operator and so on. Let's say we cut that out. And then you might think, okay, we can now get rid of that forward declaration. Okay, and then maybe do it this way around. Again, you will also get a bunch of errors. A is not a class or namespace name. So when it reaches this line here, it doesn't know what A is. So I'll undo a couple of times. And I want to remember you that this is for members, so member variables and member functions, because sometimes you have helper functions in the private section as well. Let's say class B has its own toString function now, and all that does is it prints out this member right here. But of course you can have a regular toString member function of class A. Let's say class A has its own members, and you want to print those out, or something like that. Again, this is just an example. But what you can do now is, you can do b.toString. Now remember, this here is not const, so it will complain. So what you can do is qualify this here as const as well, and then this here will be fine. And that works fine as well. Finally, I'll go and comment these out here. And now we'll try and define these functions within the definition of class A. Comment this line out, we are done with that. I just wanted to demonstrate here that if the function is not a friend, then we cannot access the private members as we are trying to do here, and you'll get an error. Okay, so we are done with that. But you can see we get a red squiggly here, so if I try and build and run, you'll get an error, use of undefined type B. And you might think, well, that's weird because we have this forward declaration of class B here. Well, one thing with forward declarations is it's fine if it is a reference, so in this case it's a reference to a B constant, or it's just a reference to a type B. And the same with pointers as well, if it's a pointer to type B, then it's fine, but as soon as you're trying to use it, so in this case we are trying to do B.toString, it doesn't know what that is yet. So those members actually need to be defined before you go and use them. That's a bit of an issue when you use forward declarations. Again, it's fine if you're simply using it to specify the type for a variable or a reference or a pointer, but as soon as you're trying to use the members now all of a sudden, then you'll get an error. Since class B has been defined right here, this will work just fine. So I hope you found this section interesting. We can also specify friend classes. In the definition of a class or struct, you can grant friendship to other classes or structs. The member functions of those friend classes or structs can now access the private members of the friendship granting class or struct directly. So let's say we have multiple functions in class A now, and we want to make all of those friends of class B. It would be tedious to go and specify each one of those to be friends. So instead what you can do is, you can specify the entire class A as a friend of class B. Now that being said, I would like to remind you on the principle of least privilege, so only grant friendship when it makes sense. And for the most part, you should try and avoid doing this, granting the entire class A friendship to class B, because all of the member functions in class A would now have access to the private members of class B. Again, typically you want to avoid that, but just as an example, we'll write it like this. Now, since within the class B, we have granted friendship to class A, this toString function within class A will have access to the private members of class B. So in other words, the function right here and the member. Okay. So we can still do this right here. This is again the definition of the toString function for class A. So we can do this right here, b.toString. Or we can do this here, b.member, to access that member directly. It'll print out 5 twice now. Okay. And then in main I do the same thing that I did in the previous subsection. I'll just pull and run this and it prints out 5 twice, as we would expect. Remember in some of the previous lessons and some of the previous lectures I talked about member access modifiers, and that I'll come back to it in the future. Well, here's a bit of an updated version of this slide. Public members again are accessible using the dot or arrow operator. In other words, those members are accessible wherever you have an object, so you can do the object name dot and then access the member, whether that is a function or a variable. Then private members are accessible by member functions of the same user-defined type. And as we've seen in this lecture, they are also directly accessible by friends. So friend functions and friend classes. Then a few final notes and a summary here on friends. Friendship is granted explicitly. What does this mean? Well, if class A is a friend of class B, then class B is not a friend of class A, unless explicitly specified, so unless that friendship is granted in that way explicitly. In other words, your functions and your structs or classes cannot declare themselves as being friends of some other class. That has to be granted or specified explicitly within the definition of some class. And then, as I mentioned in some of the previous lectures, you always want to remember the principle of least privilege, which again means you want to grant the bare minimum amount of privileges necessary for the object to perform its function. That wraps up this lecture. I'll see you next time.